Good day to you all. My name is Ali Abdullah, and I'll be hosting the conference today and taking all of your questions. Please feel free to participate in the training by submitting your questions, and you can change the settings to send the questions to everyone, or you can send it directly to me, and I can coordinate it with our trainer today. I'd like to remind you that the recordings of the training session will be shared with you after the conference has ended, and also the presentation slides. So I kindly remind you not to make your own copies of the recording. You can follow us on YouTube by subscribing and keeping up to date with the latest information. And also we have a podcast called Energy Talks, where we bring experts from the industry and OMICRON experts. OMICRON has many online trainings and physical trainings. You can find out more information about this on our website. Today's morning session will be conducted by Burak, following which we will take a lunch break, and then we will start with our conference, where we'll have 4 speakers from the industry with many interesting topics on the topic that we are interested today, which is the future of digital substations. So I'd like to introduce our trainer for today. I'm honored to have Burak join us. Burak has received his bachelor's degree from Electrical and Electronics Engineering at Mersin University in Turkey. He worked as a protection and control engineer at National Transmission System Operator of Turkey. He was part of the team commissioning the very first IEC 61850-based substations, and he contributed to the National Defense Plan of Turkey to be a nationwide standardized, and now he is in OMICRON. He is a product specialist for IEC 61850 substation automation system testing solutions. He also works on IEC 61850 SCL engineering topics for supporting utilities in this area. Hopefully you will enjoy this training, and during this training he will be creating specification of virtual IDs and how to match them to physical IDs. We will see how to validate these IDs with data models. Okay, I'd like to hand it over to Burak. Over to you, Burak, and looking forward to the training.
Thanks, Ali, for the nice introduction, and hello everybody from my side as well. My name is Burak. As Ali mentioned, I was working for the National Transmission Utility of Turkey for 8 years, and then I moved back to OMICRON. Just to summarize what I'm doing in OMICRON is it's a combination of like 3 event schemas, as you see. So basically I'm working for the products in the 61850 solutions of OMICRON, StationScout, IEDScout, and today it will be a topic to mention OpenSCD as an SCL configurator, as an open source SCL configurator supported by OMICRON. We also do some project support in OMICRON for the digital transformation of the utilities to digital substations. So some of the projects I summarized here, maybe you can already see some of the utilities here in this project's diagram, and some events I try to join from time to time. Yes, Ali, please. So for the agenda today, we have divided the agenda to 3 parts. One is the specification of a digital substation automation system, and we will play the role of the utility engineer in this part of the session. The second part followed by the system integrator role, which has the task of engineering of a digital substation of the substation automation center system, and then followed later by the testing of the digital substation automation system. And that role is the role of the system integrator again, but this time in the field where the commission engineer really loads the IEDs into the devices. Yes, Ali, please. So as the first role is the utility engineer, here we have the task to specify for the upcoming tender to build our digital substation. Next. And as we have the input only the 61850 standard, and we know what to build as we are building our substation, we have our single line diagram already. And here in this role, the tool that we can use as a system specification tool defined in the 61850 standard but as we mentioned, it's optional because you can specify a system also without any tool. So we will also cover this part. And as output of this task, we will have an SCL file if we use a system specification tool, or we have a tender document, which is basically a document, and we can also use this for our tender. And additionally, just one more. Additionally, we can have the basic application profile, which also helps us to specify the task of the system integrator. Finally, we would have a single signal list and interlocking diagram. Additionally, again, if we don't use this basic application profile, which I will cover in the upcoming slides. Okay, next, please. The second role is the project engineer, which has a task to take over. So it's a role of the system integrator. And here the project engineer has a task to create a system configuration file in a digital substation automation system. We would have the input as the single line diagram, which is taken over from the utility engineer. And then the output of the work, we would have an SCL file that would be a system specification, or it can be a tender document, which is basically a document file. And the next is the basic application profile I will mention later, or this could be also a single line signal list and interlocking diagram. The tool we would use in this case is the system configuration tool, is the SCT, the abbreviation defined by the standard, to engineer the substation, digital substation. And additionally, we could also have the IED configuration tools, not really loading to IEDs, but making the preparations for the commissioning engineer to configure the IEDs with the proprietary tools. Then later we would have the test tools to create the test files in Office, and then we will execute this in the substation. The output of this work would be again an SCL file, but this time the format will be different than the previous one, and then the proprietary IED configuration files to be loaded to the IEDs. Finally, we would have the test files to be executed by the test set in the substation. Okay, the next role would be, please have the next one. The next role would be the commissioning engineer, which has the task to go physically to the substation, later maybe virtually to the substation, remotely maybe, but now we have the task to test and commission the digital substation. And again, we take over the tasks or the output of the tasks of the previous role, the project engineer. They would have prepared an SCL file for us, and then we would load this file to our IEDs, to the devices, and then we will execute the test files. There, we would definitely use the IED configuration tools. We have nothing to do with the system configuration tool because this is done by our colleague previously, but we have the test devices nearby. We need to execute this test and then finally commission and energize, if possible, this error-free system. Finally, we would have a test report and an as-built or a final SCL file to be delivered back to the utility engineer. So that would complete the roles that we will cover today. Next, please, Ali. Okay, so what you have seen until now in these three rows would have a common denominator. That's the SCL file. So the tasks shared until now is an SCL handover, actually, procedure. The format can change. The content of the SCL file may change. It will be added more and more until you came to the commissioning stage. But the common denominator here is SCL file in different formats. So even from the specification, even there is nothing really defined for the substation, we can start already creating our SCL file with the format of SSD, which I will also cover later. And then we go on with the CD file, and then later the test this file is really running in the network with our devices. Next, please. So why do we need to make a 6950 specification? Because we need to have the full control over the project as utility, and then we know what is going to happen at the end of the specification phase, actually the configuration phase, and that will be aligned with our project requirements. So we want to build nowadays more and more typical substations, and that will be a first step for top-down engineering. So specification would be the first step for top-down engineering. And as we build many substations with the renewables coming into the, and with the battery energy systems coming more and more, and this would increase the number of substations, but we want to have really the standardized naming conventions in 6150 based substations. As I'm imagining, all the substations for a long time are already 6150 substations, digital substations, but maybe some of them has different namings, but we want to have the functional namings, which allows us the utility-wide naming convention in the entire grid. And we want to have this functional naming to be applied, and at the end we want to have a vendor-independent 652 substation. That will be a typical substation valid for all the next substations. That also opens a new door to really create a test plan, which is a template-based and applicable for all next projects. So we keep our library, a template-based test plan, and then we will apply this for the next projects also without making many changes, dramatical changes. Finally, it might be useful if we already make a pre-qualification to select the IEDs, which is only complying our specifications, but not all of them. So we can say already before the tendering stage that this and this and this complies with our specification, and we want to go ahead with these IEDs or vendors or system integrators whatsoever. Please, Ali. But the experience until now was not so optimistic, because we have seen really that the tenders has a description of the 650 implementation, not with details provided. So it's basically saying in one sentence that the substation will be based on 650 protocol. That would not help us to really have the full control over the project, first of all. So that's why this is the initial point where we want to specify our substation before the tendering stage. Next, please. And often there was the schema-based specification, even still with the 650 substations, where we define maybe the ANSI codes and the protection, control, measurement functions over the single line diagram with the primary equipment, and allocate the IEDs as boxes, which has tasks or the functions to be taken from the single line diagram. We show the primary equipments and then the allocations for the IEDs into this primary equipments, which are the functions abbreviated with the ANSI codes. That was the traditional way until now. Please, Ali. But there is a new way, actually not so new, but we started to see the implementations more and more in the coming years. So basically, there are the basic application profiles defined in the standard -7-6 already from 2019. This allows us to define the guideline for the definition for these basic application profiles, and what is a basic application profile to really define. We need to go back to the roots of 6150 and recheck again what was the 3 main goals of 6150. So the 3 main goals of 6150 was, first of all, the interoperability. We really want to have these IEDs talking to each other with the common protocol. We want to have a long-term stability. Even the communication would change one day, but the application will remain as the same, so it's already the same. But there was also something as pre-configuration. Yeah, and this led to some results that we will see. So we have seen a lot of 650 substation, which with this pre-configuration allowed us to freely define the data model, the signal flow, the communication services, and really without any standard naming convention. Maybe this would result on also with some substation with fully GGIO utilized, and there is no logical node usage. The semantics are lost, and then we convert 6152 into a data point protocol like 104 or Modbus. And that was not the case that we want to achieve with 6150. But there was another way we can follow, and that will come. That will be something that we can use the basic application profiles, which can be in 2 ways. One would be defining an file, but that will be also a document. But in this document, a basic application profile can define a standardized data model. And it will also help the system integrator to select the data model elements, basically the data sets in the signal flow for the services, goose, report, and sampled values. Also, the control block parameters even can be defined already and standardized with our naming conventions. The logic can be included in this document. The naming rules can be also included in this document to guide what to choose, what to really name the parameterization stage of 6150. And it's not a fixed document that we can have just one document for all applications or all different topologies. We can have different variants for different topologies. For instance, an double bus bar with bus coupler would have a different application profile variant, and 1.5 breaker substation would have a different application variant. On the other side, we can have a merging unit with sampled values, or 2 merging units even, which would be a different variant, or we don't want to use sampled values at all, and then we can have another basic application profile. This is all possible. Okay, Ali, we can move on. So, as mentioned, basic application profile can be a document or an SCL file format, which is an ASD format. I hope it will become more popular, but the basis for the specification, which we will cover today, so we will not create a basic application profile, but we will create a specification which helps also us from the basic application profile to have. Yes, please. So one example, we can have a look for a basic application profile, how it looks like. For instance, we can, as I said, define an application called interlocking, and together with the synchro check maybe, and then we start to create the description and the use cases and actors and functions. So here we define what's the role of the actor here, what's the description of this role, and then we can define the information flow. We can say how we want to communicate the disconnector position out using which logical node, and then what's the information flow, which services we need to utilize for sending out this position. Is it a goose, or is it a sampled value on report, or what kind of communication interface we will use? It can be also a copper wire, then we need to mention it. So the logical nodes, the data objects are already decided, so there is no freedom, we can say, left to the system integrator. So everything is decided already. And then we move on with these UML diagrams, which we show the functions are the associations with the functions with the roles and actors. Next, please, Ali. And then we can say, so these functions will be communicated out using this service, and this function will be communicated out. Maybe it will stay internal in the data model. It will not be communicated out. We can use naming rules, which we defined as a functional naming document, and then later we can also define the capabilities for testing. So if we need the LPHDCM, the simulation flag, we define it here. If we need some algos and LSVS, we need to define also here. Then we can have all the information related, then we leave no freedom for the system integrator, which helps both sides to really know what to do, and then everything is already defined. Is this basic application profile? Good. So how is the engineering workflow when we consider also the part for the basic application profiles together with the specification? As I said, we have the role of the utility, which needs to specify. And then we have the role of the system integrator, 2 different user group here, because the system integrator would have a project engineer and a guy in the substation as a commissioning engineer. Okay, for the specification, we can do this using 2 different tools. We said SPT is an abbreviation for the system profile tool, and then we can have an ASD file. Or we go with the Office tools, really, we don't need to use any other SCL tool for this. We can have a document format as BIP. And using this BIP, we can create the SSD file, because in the SSD file, we need to create the functions that will be taken over from somewhere. Yeah, otherwise, we use our own imagination or the requirement document to create an SSD file. And this SSD file would be created using a system specification tool, and here it's abbreviated as SST. And then at the end, this SSD file can consist some virtual IEDs. Yeah, we allocate the functions to IEDs, and then we know a virtual bay controller, we have a virtual protection unit, and we know which functions will be taken over for which unit here. Okay, once we have the SSD file, there will be an input for the system configuration, and then this will be in the system configuration tool handled. But there would be also something called ICD file, which is the IED capability description file taken directly from the ICT tool, the IED configuration tool, which is a template file, an empty file, which doesn't have anything in it, but the capabilities of the IED. So what can an IED do? So we need to match these capabilities, the physical capabilities of the devices with the virtual IEDs. So we will find a balance, or we will give some compromise, or maybe the virtual IEDs we specified is perfectly matching with a physical IED in the market. So that would be the best scenario, of course. And at the end, we will utilize the SCT tool to engineer the services, the glues, client server and sampled values. And at the end, we have an SCD file. Then we hand over this SCD file to the colleague in the substation, and they will use this ICT to load the configurations to IEDs. Of course, he or she, they can extract the CID files and then load to the IEDs, and they will run the configuration. Just the additional arrow here at the top is the ICT files, the capability descriptions are coming from the ICT tool. So they can only know what their IED can do. Okay. So this is the basic workflow, which we will also follow today, but in 2 hours, we will do our best to make a mini substation. Okay. Good. So the task for today is now creating a specification SCL file first, and we will now play the role of the first user group. That's the utility engineer. So next, please. We will use a substation for 5 bays, but just for the sake of simplicity and the time, we will only engineer 2 bays. One is a typical line bay, and then we have a physical ID here, yeah, with me on my desk. And yeah, by some possibilities, we couldn't bring a bus coupler maybe in this scenario. Then we will use the tools to simulate this bus coupler to check the configuration of our ID, which can be a typical use case. And here on the specification phase, we will define the functions that the line bay will take over. And then we will have many boxes in most cases. That could be a merging unit with the substation control unit or switchgear control unit here, and communicating, so it's wired with copper cables to the switchgears in the switchyard, and then communicating out goose and sampled values up to the IEDs in the control room for protection and control. And these boxes here, we combine them as one box, and then we will skip the merging unit and SCU also. So we'll have the ANSI code functions here, the distance, you can see some auto recloser, some overcurrent or directional earth fault, and then power swing blocking. And then also we will have some bay controller functions here, another IED maybe, and we will have this specification created by a tool. And another IED that we will also create for specification is the bus coupler. Next, please. That's a bay where we have some switchgear, some busbar grounding switches. And again, we will have an merging unit plus SCU, then we can call it a process interface unit, but we will skip this for this training, but we would also engineer a bay control unit for this bus coupler bay. And there will be some communication services with these 2 bays. And the data model should look like something that we normally could have from the BAP. BAP should really guide us how a data model could look like. But again, to simplify it, we had a data model. Imagine this is a BAP, which we will have these logical nodes in our data model. So we will specify this. So to take your attention to one point, in the data model, we would have a substation section where we define these functions. So we call every process here as a function, and these functions will create eventually a logical device. Okay. And we would have some functions, as you see here, some protection functions, as well as some control functions. Okay, so you might be familiar with the logical nodes mentioned here. So we would have some distance protection, overcurrent, so synchro check. It doesn't have to be an protection or control function. Maybe a measurement is also a function, and you would also have in your substation a disturbance recorder. Maybe that would all be whatever defined in the standard as a logical node is a function, what you define in the specification. Okay, we will utilize all these logical nodes. And the next IED is the bus coupler bay control unit. Next, please, Ali. Where we would have also some commands, some interlocking logical nodes, some positions, as well as some measurements. So to create this data model, of course, we need the standard with us. Yeah, this would be the initial guide. And if possible, a BAP document, then we don't need anything really. We will just look for the BAP and then it will tell us what to specify. Okay, the next thing what we need to really keep an eye on is for creating a data model of a virtual IED or in any IED, we would have two things. Yeah, we have this hierarchy. You might be familiar with physical device in the top level. You have the IED here, and then the logical device could be many functions or a combination of many functions coming together as a logical device, which can be freely defined by the user. And then we have each function as logical node. Yeah. If you go next, Ali, we will see two things. When we define the logical nodes, we need to take care that there must be an LPHD logical node minimum at one logical device, and we must also have one LLN0 in each logical device. Okay, these are two basic requirements which we need to take care when we create the specification and virtual IEDs. Good. Now is the hands-on time, but if we move once, I will now mention what we will do in the hands-on. So as we said, now we will play the role of the utility engineer. Yeah. And what was the task of the utility engineer if we go back in the first? The task of the utility engineer is specifying the digital substation automation system, right? And then we can follow an step-by-step walkthrough where we start first creating the primary structure. So we have a single line diagram, but we want to include this single line diagram to the SCL file, right? And then we have the functions. We say that I want specifically this function protection and this control measurement. We would also create the function elements in the substation section. Finally, yeah, you can imagine there is no IED defined yet. We need the logical nodes that will come or instantiated from the data type elements. So we first need to create the data type element section. Okay, that's taken directly from the standard actually. So once at one side we have these function elements and primary structure, and on the other side we have the data type elements, we need to assign the elements to the functions. So that's the meetup of the logical node, the 650 world with the application world. And you will see the icons that we will use. Until now, as there is no IED, we cannot use our beloved IEDScout or StationScout or any other tool. We can only use a notepad to show what we have done. But later, when we come to create a virtual IED, we will see our first from scratch created IED, the virtual IED with IED browser, which is the IEDScout. Then we will move on adding some communication parameters, some subnetworks, some access points to really not physically or not defining the data model, but the surrounding the communication interfaces of the IEDs. And finally, if we would like, we can already define some settings. It could be protection settings, it could be any other settings, which is already decided by the utility, and it leaves also no need for the system integrator to make the settings, because he knows already from the specification file what are the parameters. And at the end, it's always a good decision to validate the schema and also validate the templates, what we have done. So these are the tasks we will go through together with the role of the utility engineer. Okay, I want to mention what tool we will use for doing this. If you go to the next slide, Ali. We will use OpenSCD, maybe one more slide, to have the logo of OpenSCD together with the text. It's not showing up. Yeah. So we will use OpenSCD, which is an open source SCL editor, and it's hosted at this web address, but don't worry, it also works offline. Yeah, I can imagine if you go to Substation and work, then you can also work offline. That's no problem. We have a structure of OpenSCD working with the plugins, and these plugins are used for different purposes. And I mentioned in this step-by-step walkthrough some plugin names that we will use. And please feel free to contribute to the project, because as much as we have the contribution, the project of OpenSCD will also grow gradually. So you can use this GitHub address for joining to the community with us. Next, please, maybe we can show some. Yeah, okay. So at this stage, we should go to the hands-on part. So where we left off last time was the role that we play now is now coming when I share. That's the what we start specification of our substation. So to do so, I'm just running the OpenSCD, as you see here. And here we need to specify the primary structure. Basically, to specify a primary structure, which means starting a new project, and we will use the name, the event, and use the edition 2.1 to be up to date. Okay, we have some plugins. The OpenSCD consists of many plugins to be used parallelly at the same time. And the plugins that we will use today, on the left menu, you will see that we have many plugins. What we will use today is the templates plugin, the IED substation. So we'll make one example goose and subscribe to this goose, some communication structure. So 104 will be an interesting example to show you, because we will add also some data points into SCL file, the 104 data points. And then also having a look for what are we publishing. Okay, that will be the plugins that we will use. The first plugin now we will cover is the substation. That means we will now add a substation from right bottom. So when I click this, then I will create my very first substation from scratch. That I will start creating the substation from the voltage level. The first element that I need to create is the voltage level. And here you see some missing elements, because we just started creating the substation section, so-called. That's the primary equipments together with the functions, yeah, and assignment of the functions to the primary single line diagram, simply to say. On the right, you see some icons that we can add some, different elements, and the first element would be voltage level. I will name this as 380 kilovolts. You can always have a description, for instance, transmission, and the voltage level is again the 380 kilovolts. And based on that, we can now add a bay. Yeah, that's the 202, and that was a typical line bay. Because I want to reuse this specification later on, I just want to keep this with the typical names. But if I have a specified name, I can also name this. Yeah, this is no problem. And under the bay, we need the primary switch here, right? That will be the conducting equipment in 6150 language. So the conducting equipment for this bay is typically a circuit breaker. If you remember, I can also show you from time to time here what was our bay going to look like. So this is a bay, something like this, yeah, with 2 busbar disconnectors, 1 circuit breaker, and again 1 line disconnector and 2 earthing switches. I will not create all because we are already delayed, but just show you what's our circuit breaker to create. How do we do this? In the standard 81346, we had the standard naming, and this is also the standard used in the 61. This is also referred to that. But if I have some old style naming from the DIN norm, for instance, I would use the chooser as a description. That I would also use the tools to show it like this. Okay, one more conducting equipment maybe would be enough for the moment. That would be a disconnector, and I would name this as QB1, and that would be a bus bar 1 disconnector. So if I continue like this, eventually I will reach up to a stage where I have all the conducting equipments with this naming style, right? And where do I know the names? Normally I would have a BAP, which is telling me what to name the conducting equipment. But I'm imagining now at the moment, for the sake of simplicity, I would use these 81346 names. One useful feature to show you is duplication of a bay. So if you have another bay, typically you have many line bays, then you can use this button to clone this bay. Then you have two bays. One is the Q02 as line bay, and one is the Q03 as line bay. You could do this normally. But okay, maybe better I will show you how it would look like after this process. So I will show you actually the completed part where we have one line bay consisting of this voltage transformer, current transformer, the earthing switches, busbar disconnectors, and at the end a circuit breaker. And I would also copy, but there would be some changes, because if you look the bus coupler, it looks a little bit different, where we have again busbar disconnectors, but we have also two busbar grounding switches and two busbar voltage transformers. So I also added those. Okay, so that would be the first task of the project, utility engineer. If you remember now from the task overview here, to create the primary structure. Okay, we accomplished this. But maybe one thing to show is how our SCL file looks like at the moment. Yeah, I will use Notepad for this and open our file with the Notepad. Let's have a look how it looks like at this stage even. Okay, so if I fold all, and if you are familiar with Notepad++, sorry for making everything dark theme, but we would have normally 4 sections, right? One is the optional substation section where we are engineering right now. And we would have a communication section, which is at the moment nothing. We normally would have an IED section, but we don't have an IED at the moment. Therefore, we can even not see it. And there, later in the 4th or 5th stage, we will have a data type templates. For the moment, what we have done is a substation with a voltage level, followed by 2 bays, right? And each bay has its own conducting equipments. And the terminal where you see some plus icons would have the grounding switch. The difference between a disconnector and the grounding switch is only having a terminal for the grounding switch with the grounded connectivity node. Okay, so that's how our SCL file looks like at the moment. Now we can proceed with the next step, and that is the next step called creating the function elements. Okay, so what are the function elements? If you remember, the function elements that we need to create is this ones: distance, overcurrent, synchro check, disturbance recorder, measurements, and switchgear control for the line bay. How do we do this? So a function can be a function of an conducting equipment, then it would be called an equipment function. So as you see here, you can create an equipment function, which is a function of an equipment, the switchgear. But it could be an overall function of an bay or an voltage level or an substation. So I would like to create a function for the bay itself, which makes sense because if you look now at protection function, it's not actually a function of an equipment, but a function of an bay itself. I can create a distance function, yeah, or we can call it distance protection in the description. You cannot use multiple words in the function name. and where we can have now some sub-functions even, because the distance is a logical node, maybe the protection itself, but you can have multiple states or so-called zones. Then this zone 1 is another logical node in the direction of forward. Yeah, I can create now a sub-function. At the end, please notice every function will become a logical device. Yeah, so we can continue like this, but I even want to speed up to show you where would be the final allocation of the functions in the substation section. Okay. Please notice these are only names, and there is still no logical node or a data model in our IED. So we still make our imaginary IED, the virtual IED, only with the functions with the names. Okay. Now I will open up where we have the all functions, and it looks like something at the end like this. This is completely freely assignable. This is completely up to your specification. How do you want to see the functions allocated under equipments or physically, or allocated under some base or some voltage levels? Yeah. If you look through now, you see I have created a switchgear function, and in each switchgear function I have all the conducting equipments, yeah, aligned under that. And I would have a synchro check, a measurement, also some protection functions. And maybe it would make sense to put also sub-functions of distance under the distance function. That would mean like power swing blocking for me is a function for distance as a sub-function that I would allocate it under, because it's also at the end a logical node, right? Okay, the same principle I also applied for the bus coupler. And then there I have the functions. What's the next step now? Let's have a look. The next step is now going for the data type templates. So creating the data type template section. But maybe again, at each step, what we really like to do is how our SCL file, really the code view, the XML view of SCL file looks like. So we created the substation section and how it looks like when we have the functions assigned. So you will see now some functions under the conducting equipments or some elements. Yeah. For instance, you have a function here under the conducting equipment or under the bay. Yeah, sorry. Or maybe you have a function here under the connectivity node or conducting equipment. Even you have some sub-functions. So it looks like in this view. Or if we fold all, maybe we have a better view. Again, we have nothing in the communication and data type templates, but we have a function called root. I will mention why do we have this. And then we have some functions under the base and even sub-functions. Okay. So why do we have a root function? If you remember, we must have a logical node. Even the others are completely optional, but we must have something. What was that? That was the LPHD, the physical device logical node. As we have an IED, which is a physical device, yeah, it can be virtual, but for this defining this, we need to have this LPHD. You remember this slide? We need to have this LPHD, and that's my choice to put LPHD under, no, not German, put logical node of LPHD under the root logical device. Maybe you have seen in some vendors use some other logical device names, but this is my choice to make it under the root logical device, root function, yeah. The next step now is defining the data type templates section that we will use this at templates editor for that. So to define the templates, we need some 650 knowledge, right? We need to know which logical node means or corresponds to which function. For that, we typically may go through all the logical nodes. For instance, I can show you the simple example of silo. Here in the drop-down list, you see all the logical nodes defined in the standard. Maybe at this point, it's better to have the standard with you, 7-2, 3, 4 parts, because here you need to decide. For instance, we defined the silo, and what was the silo? The control interlocking, right?
for defining an interlocking, you will see different levels. So here is the data objects, okay? And then the next is the data attributes, and the green ones are the mandatory ones. So for each logical node, the standard defines some data objects as mandatory and some other ones as optional. And here, the editor already pre-selects the data objects which are mandatory, and it leaves us, for instance, what I want to have is for an silo, maybe, I don't know, something, it's not a good health, yeah? I would also have the health, and then under the health, what you would expect is the status value, QT, but maybe something else. Maybe you would also like to have a description that's D. You can add that. And under the status value, you would have normally 3 different status data attributes, or the statuses. Yeah, under the data attribute can be alarm, okay, and warning. If you have all, then you would have only these possibilities, or if you have only alarm and warning, or alarm and okay, your IED can only have these different 2 statuses, but nothing else. Okay, but normally, how is an silo looks like? It's with enable open and enable close, and in each data object would have the status value Q and T, right? So this is for the enable open and enable close the same. And whenever I say add type, then I would have my very first logical node in my IED. So at this point, we are starting to create or build up on the section called data templates, data type templates, right? Based on the data type templates, the IED will instantiate the logical nodes. One more example, maybe we can have this, for instance, LPHD. As we said, this we must have anyway. So under LPHD, these are the mandatory ones. And maybe I would also like to see how many times my IED is powered up, right? Then this is my choice, which is mentioned in the BAP maybe. And then we define or specify that my IED would always have an LPHD with power up, and there would have the status value Q and T. Okay. And one thing for especially testing, you may still know maybe that the LPHD consists of a very important data object called sim. The simulation flag allows us to receive simulated values or not. So based on the status of the simulation, we can decide we receive a goose or sampled values, which is simulated by a test device, or we receive a value from a process device, which is a merging unit maybe. And we can add this. Why it was not gray? Because still in the standard, the sim is not mandatory. But we definitely would like to have it. Then we click sim. And you may know the sim is a controllable object. And each controllable object in the standard always comes with a control model. Then you can already pre-select which we want to have and direct with normal security maybe only, not select for operate and all other possibilities. So we limit it only to direct with normal security. You can even not select other ones. But there comes with another flavors. So oper, the select for operation timeout, and under the oper you have also the originating category. Maybe you can have this controllable object controlled by remote and station. So there are also many other possibilities when we build up and controllable object, which we need to also add additionally. Okay, so that was the example for the LPHD, which we would have also something. You remember we have this physical health and physical name, the nameplate information, yeah. And one thing we must also have is power up, proxy, and the vendor name. And here you can have also a serial number, software, whatever you want. I will show you at the end how this process looks like, so how our data type templates looks like. So at the end, our data type templates would be something. I can also use this templates plugin to show our data type templates allocated in this IED. I would have the recloser, the CSWI, the fault locator, the power swing blocking as the logical nodes. Yeah, and under these logical nodes, I have some mandatory, no, all mandatory, but some optional data objects and data attributes. And what's an enumeration type here? the enumeration would be something like originator category. We would have remote and station. And if you remember, normally we have more options, but I reduced them to have only the remote and station. So not really the local or the automatic ones. Yeah, good. So we have our data type templates now. We have an selection of the possible functions to be assigned to the functions that we created. So what we will do is bring the data type templates together with the functions. Okay. Before that, we always do something, and that was looking how our step looks like in the Notepad++. Yeah. In Notepad++, we would expect something new. So we are always adding more and more details to our SCL file, and now we have the data type templates. And you may ask, what's this $sign? It's the unique ID for the logical node. So it can be anything, but here we use OpenSCD as editor. Please remember this, because in the later minutes, I will show something in the real vendor. How does this ID looks like? Yeah, this is a specification logical node type. And under the logical node type, you have the data objects. For instance, this is a TVTR. The ones that you know what's a TVTR. This is a voltage transformer logical node, which would have anyway a behavior because it's mandatory, but something else as maybe the sampled values, maybe the fuse failure, and something any other thing. Okay. And the relationship between the behavior and the mode, maybe you know, we would have a mode which controls the different test modes, and at the end we have a behavior as a resulting a matrix of the different modes in different logical nodes based on some inheritance. You definitely don't need mode in every logical node. You may need it in some, and even you have mode, it doesn't have to be controllable. It can be read-only. But I think we have the mode in the in somewhere. If we search here in the LLN0, right? In every LLN0, we would have the mode, and the mode can be controllable or not. Okay, but you would also have the mode in the silo, for instance, if you would like to have it. How can you do this? You go to OpenSCD and in the add templates, and here you would select the mode as, so for the silo, if I would like to have the mode, I would just need to enable it from here. Then I would have a mode. So as I said, mode can be controllable or not controllable, but the resulting behavior is a combination of different modes in the root logical node, but I don't want to go into details for that. Okay, so the next step. So the next step is now going to one step more. We said now it's the time to assigning the logical nodes to the functions that we created. So we come back to substation section. We have, for instance, a measurement. And what reminds you when I say measurement function, what's the logical node to assign? That would be most probably an MMX related one, right? Like MMXU, right? If we have the MMXU in the templates, then we can assign it from here. So I can see there's an MMXU. Or if I can imagine for a larger substation, you have many logical nodes, you need to search it. Then you say save, and it appears now an logical node assigned to this function. And later on, you will see we would have a logical device called measurements under this logical node. Now we are building the blocks of the data model. And then under that, there will be one logical node. It can be also multiple. Yeah, that's no problem. And if you look more detail of the logical node, here you can see the logical node. If there's a prefix or suffix, but we will come to that later, then it's also be defined like this. The code view we can also have with this icon. There we can see, yeah, it's a bit smaller, but I can make it larger for you. Here we can also do the manual editing if you want, as an expert tip here. Good, I can continue like this. For instance, one more switchgear assignment I can make. If you just think about one switchgear, what could be the possibilities? I would definitely want to control it. And how do you control a switchgear? Using a CSWI, right? Then I would assign an CSWI to a controllable object to my switchgear. Maybe I would also like to have its interlocking, and I would have a silo for that. And maybe I would also like to have the primary switchgear information. That's the X-related logical node for this switchgear. This is the famous 3 logical nodes you can say for a basic switchgear type. I can continue like this, but I again want to keep the pace. Then I would show you how this process end up at the end. So at the end, we would have the functions assigned to logical nodes. You see so many functions now assigned, right? You can imagine that would also continue like this. At the end, I would have one line bay, and then under this line bay, one IED, but still the IED, I have it in mind, but I haven't started to allocate which functions my box, my IED would consist of. That's the next stage coming now. Okay, let's look through. For the protection-related logical nodes, I would have an overcurrent, I would have an QTOC, I would have a disturbance recorder, would have a power swing blocking function, the fault locator. Just maybe I use some descriptive tags here for that. So at the end, my ID is starting to shape up. Good. So after that, let's have our final look before we create a virtual ID to our with our open Notepad++, the final look of our data type templates assignment to the functions. So I can see this assignment here. If I go to substation section, I have a function, but there is a logical node now. This is the difference. Okay. So the allocation of the route to the bay or to the substation, rather than having it to an voltage level, is completely based on your design, I would say. I would also have a route for bay and another route for here, but I want to share the same route. That's why I put it to the top. Why I put it to the top? Because I would like to use the same LPHD for both. Then it seems as a good design, but maybe you think different. It's completely up to you to have another route under the logical under the bay, or another route under another bay. Just want to share the same logical device for both IEDs. Okay, that's the only reason. It's just a design topic. Good. I will create now my virtual IED. Okay. Then I need to use another button here or another plugin. So to say in OpenSCD language, that's the create virtual IED. When I click to that, then it asks me who is producing this IED. So I don't know yet. It's a specification IED. Okay. But I would definitely need an access point name here. Maybe I can name it like access point 1 or access point station bus or access point process bus. It's up to you. So which IED are we creating now? Maybe we are creating the line bay protection control. That would mean we need to assign the logical nodes of the line bay. You remember the line bay? We would need a synchro check. So we would definitely need to use this Q02 once that I need to click all the Q02 logical nodes. Okay, I will not click all. So just to save some more seconds. Okay, so the ones that you don't hear me, maybe I use this head speaker, that one. But at the end, we will have the logical nodes for Q02 starting from here. I will click all, just imagine like that. And I will do the same for Q05. And at the end, I will say save. That would create my first specification IED. This is our first virtual IED that we created from scratch. And the standard says name it as specification, but further on we can change it as line bay protection control unit. Okay. And then we will save this. And here we have our IED. And if you go to IED plugin, then I will see what I have created. So we have created an IED with the access point AP1 that would have an MMS server inside and have some logical nodes, some data objects under it and some data attributes. Yeah. This we can see our IED already. Some PTOC for overcurrent protection, and always don't forget that there will be one LLN0 for each function, but actually it's a logical device now. If you remember, every function eventually end up with a logical device. Okay, I will show the end of the process also for this step. I have now two IEDs, two virtual IEDs. As you can see here at the top, I have one line bay controller, protection and bay controller, and one bus coupler. At this stage, now it's time to use an IEC browser. We don't need maybe to use the Notepad++ anymore. We can use IEDScout. I go to IEDScout, the browser page, and open my SCL file, which was at the stage of creating the virtual IEDs. So here. Now I expect to see two IEDs, which I created from scratch based on my basic application profile, if possible. If not, based on my design. As you see, there is no GUIs, no reports, no setting groups, no files, or no datasets even. There's only data model. And data model looks like what I have really written down as a function and the logical nodes under this function, which is actually a logical device, right? And as you see, I have the behavior. Maybe I make it bigger to show you, or without the monitor. Yeah. I have this CSWI, the position of it, the control model, the SPO, the OPER, then I can control this. So at the end, I have a root logical device where the LPHD is located. LPHD can be located any other logical device, but the logical device which LPHD is located under would be the so-called root logical device. That I would really like to make it separate. Yeah, this is just my personal choice. Let's have a look also to bus coupler. It's a simpler IED with a simpler data model. I would only have some measurements, and here you see some face-to-face values, voltage values, some frequency, and one health, just as an example. Okay, I think what I have created now is something we wanted to have as a data model, if you remember here, this slide. So I wanted to have this data model, and I think I have created something similar to this data model, what I have defined already. Good. Now the job of the project engineer is easier because he has already a data model. He doesn't need to think about which data objects, which data attributes, which logical nodes will be utilized. Let's go to the next stage now. We created the logical data model, sorry. And now we can have the virtual IEDs. The next step would be some communication parameters. So we can add some subnetworks and assign these access points to these subnetworks we created. Did you remember this access point we created? We say it AP1. Yeah. We will do this. This is relatively simpler step. We go to communication plugin, and there's no subnetwork. So these two IEDs, we want to collect them in the same subnetwork. Then I call it maybe station bus. Let's send 100 megabits, yeah, basic network. And then the next stage would be now adding the access points of the IEDs to this subnetwork. You can imagine an IED can have multiple access points connected to multiple subnetworks. It could be an process bus access point under the process bus subnetwork, right? With different IP and the subnet mask details. I would select these IEDs just for simplicity, but the big picture I think you can already imagine. And here, what I can enter is already the IP addresses of the IEDs, if there is any. Yeah, it doesn't have to be actually, because I'm specifying, but maybe I want to also specify to make things a lot easier to the project engineer. I also would like to specify the IP address because I have an IP addressing schema in my utility maybe. I don't leave freedom for the IP address parameterization maybe. Okay, and as you see, our schema validation is already successful because we added the required elements already to the IEDs. We will do the same for this, but just let's skip this for the moment. But then we have also the communication parameters. So am I saying the right thing, or am I saying the truth? Let's also double check with the notepad one last time. After having the access points and IP addresses, we can now have a look over XML structure. We said now we have another section. Maybe we have another section, that's the communication section, where we have the IEDs with the access points here, the IED name, and even the IP parameterization here, right? Good. Maybe you noticed we already have the IEDs. So we have another section actually, that's the IED section with a server and already the instantiated logical devices and all the data model. What's missing now? What's the missing point? What we haven't seen until now is the communication services. So we haven't defined any GUIs, reports, and sample values. That's possible, actually. We can also define the specification, the communication services, the GUIs, the data set, everything. But yeah, we have to save some time. But just please be informed that it's also possible to specify the communication services. Then there is really nothing left as just to find the right physical IED matching with your specification, which consists data model, communication flow, communication parameters, yeah, more or less everything. Okay, the last thing is maybe setting some values. Yeah, what left out, maybe there's some setting values. We can set some default values that we have already some protection values, for instance. Yeah, let's go to our IED, which is the line IED. I select from here, and then I need to find my logical node, which has the time over current setting under that. So having the setting in the 6950 data model is again not mandatory. You can optionally have it, and if you have it, here is the start value of this PTOC, the first stage of it. And if you have it, you can also have the setting of it. And you can even set the value for that. Yeah, you can set this value. That's also possible to set this value. Okay, we can set this value, and then we have it in the data model. Okay, so we have set the value of 500. And is it really like that? If I go to IEDScout to check, or can change it to 1000, whatever you like, or here also the time dial of it. But just imagine you can also do that. You can add all settings, but just to check in the line IED, I have the PTOC and I have the start value of it, 500. Yeah, even the protection setting is inside the data model in the SCL file. So the standard allows us to specify also this. Good, I think that would be the last step for the utility engineer. Now the utility engineer can hand over, maybe we can validate the schema and validate templates. So what's this now? We need to validate the schema is valid for 2007 B4, which is the edition 2.1. We can do this with one click. And what's the validation of templates? So in the validation templates, we are checking what we have as the data type templates is really matching with the instantiated data model of the IED. So is there a discrepancy? Is there a mismatch or not? We need to validate also this. So the templates must be also valid. We also did that. And now our task is done, actually. Now we have a file we can hand over to the project engineer. So at this stage, I would go back to my presentation with 2 more slides, because now we need to play another role. So we have to now take over the specification file, actually it's an SSD file, and try to find if, as a project engineer, I need to buy some IEDs which is matching in the market with the virtual IEDs that is created by the utility. So is there an IED like this? Or which vendor supports this? Or is there any vendor supporting this virtual IED, the data model, the functionality, everything what's possible. So we now go to the market to check the dream ID is matching with the real life. Sometimes it's not, but of course in this training, yeah, everything is possible. And now we go to the market, and the market that we will go is the market of Siemens. So I will open up DIGSI. That as a project engineer, I will check if there is a Siemens IEDSC Protect 5 IED matching with the specification file. I again start from the scratch. So as you see, there is literally nothing. I will create a new project, just name it the Future of Digital Substation Automation System project. And for instance, DIGSI offers a function to import my specification. And here, that function is under IEC 61 substation. And I will try to import my specification file. So I will select the file, which was the file that we engineered. That's the file number 10, the utility project from the OpenSCD. Just at this point, I need to explain the file format is SCD, but the content is SSD file. The extension is not really matters. Okay, you can name it SSD. The OpenSCD always saves it SCD, but just name it. Even you don't need to name it because it will pop up like this. So now DIGSI recognizes my data model. It will show my functions and even showing my substation section, and it will show the logical nodes. So, but I have no IED at the moment. I need to offer some IED. Yeah, I need to use an IED from my warehouse, which I plan to use if possible for this project, that I will import. Maybe for this project, I see the candidate as 7SL87. Yeah, maybe it could be. I saved this default file of 7SL87. There is really nothing in this file in the data model. I will show you. This will take some time. And at this point, maybe it's a good time to answer some questions, Ali.
Yeah, I think some of the questions you might have answered. There was a question regarding the simplicity of so you, for simplicity, you were using only one IED, you mentioned.
Yes.
But typically, how many IEDs are there for a bay? Is there a specific number?
This is a good question. It's completely up to the design, but what I can really share with you is it depends on the transmission level. So in utilities, in digital substations, basically we must need, if we need to use sampled values, we would need an merging unit. The number of merging unit could be 1 or 2, yeah, because you can imagine in the transmission level you would have 2 coils and 2 CT cores, maybe just taking the information, and 2 protection IEDs, yeah. So then it makes a good choice to have 2 merging units at this point, maybe, or you can have 1 only. And the SU, the switchgear control unit, is a device which receives the non-analog information, the binary information from the switchgear, binary inputs, and converts it to goose and sends it out to the protection and control units. Yeah, but we can combine this with one box. Typically nowadays, the merging unit and SU becomes one box called PIU. But this can be doubled, as I say, maybe in distribution not, but maybe in transmission, yes. And then you might have possibly 2 independent protection IEDs and 1 separate control unit. But this is completely up to design, yeah. Any utility can decide any number of boxes, or you can put all in one box. This is completely up to the design, but of course the reliability concerns made it possible to have some redundancy mechanisms, also the device redundancy. Then we would end up with 2 protection units, 1 bay controller, or even 2 bay controllers, and maybe 2 PIUs. Yeah, I can answer only with my personal experience, but there must have many more different variants and the flavors of this to answer this question.
Mm-hmm. And if you have IEDs that are tripping circuit breakers through a merging unit, how do you display this in the data model? How do you define it in the data model?
Yeah, typically a merging unit would have the TCTR and TVTR logical nodes, as we mentioned already here, the TCTR and TVTR. This is for the data acquisition from the TTs and VTs. But if we also trip the circuit breaker, then we need to allocate the functions of XCBR, and then the CSWI. So we need to divide or break up these two logical nodes into two different boxes. So at that case, so the arrangement would be something like the PIU would have the logical node of XCBR, which is the ultimate tripping. So this is the link to the trip coil. And then this XCBR information is receiving a goose, which is a trip goose from an PTRC of and master trip information of any protection functions logical nodes. Every protection function will have initiate or trigger the PTRC, which will send out the goose, and that will be sent out maybe by a trip goose. Then the XCBR will allocate it and eventually turn it to an binary output to trip the trip coil of circuit breaker. So we would break up the logical nodes in this case. But for simplicity, as I said, I have taken the XCBR and put it to the BCU as well, together with the CSWI.
Okay, perfect. I'll let you continue, Burak, but just maybe I'll mention a few things to the audience. Normally, we should be finishing the training in 8 minutes at 12 o'clock Central European time, but as mentioned, we will continue because we had some technical issues so that Burak can do the complete training, and we will be sharing the recording of the training and their presentation slides also. So for those who cannot stay after 12 o'clock, feel free to drop off, but we will continue with the training. And then we will have a lunch break, and then the main conference will start at 1:45 Central European time. So hopefully you can join then as well. So continue, Burak, and no rush for you.
Yeah. But it would be good at this point to maybe set a time, at least to mention to not to eat up from your lines. So I would say we will end the session in half an hour. That will make in the Central European time 12:30. So I can imagine we will end in the 12:30. At least I will try to do my best to complete at 12:30. Good. All right. So we added one IED from our warehouse. That's the 7SL. But we need another one, because if we now check here this checkbox, it will try to match this with 7SL, but I need another 7SL because I have two IEDs and I have to match it with two physical IEDs. So I will add one more 7SL, 87. Maybe it doesn't make sense, maybe it's too much for a bus coupler. Please ignore all the details. So imagine I would really also check the economical conditions to really find the best matching. But for the simplicity again, so I will use another 7SL. Good. So I have two 7SLs. You can already see they support 6150, and their structure is the default structure. What's the structure? So IEC 6.1 structure is the data model of the Siemens IED here. And the Siemens IED has the default logical nodes. Every function element you see will be the logical device, and then followed by a logical node, followed by the data objects, up to data objects. Yeah, it will show you. The further information is the data attributes. We don't see it here, but it's not so big deal not to see it here. What we want to see at the end of the process is this data model will be converted to the data model that I specified. So is it possible to match? That's the thing what we are trying to do. I go back to my specification window, make it a little bit larger, and now start to match an IED with my virtual IED. I want to use the first 7SL for bus coupler, and then the line for the other 7SL. Basically, they have the same data model. And here you already see there is a match of 6 logical nodes, and there is no match of 1 logical logical devices and one logical device is not being found. This algorithm in the DIGSI works automatically to try to match my logical devices with the data model. If there is no match, he will inform me, they will inform me, then I will try to find another logical device. For instance, root. Remember, the root was the logical device which consists of the LPHD. You need some Siemens knowledge here, the Protect knowledge. You know that the application logical device corresponds to this logical device because under that there is an LPHD logical node, which could not be found, but I know that there it is. Why it's not found? Most probably we have the name LPHD1, but Siemens offers the name LPHD0. But now we have a perfect match, okay, for the root logical node. All logical nodes, even under the data objects, are completely matched, yeah, up to the data attribute level. So whatever we specified is matching with only one exception of QA1 and the measurements. Let's look through what's not matching. Here, the synchro check logical node could not be found. But let's see if there's a potential candidate. Yeah, there is one. Yeah, we can select this. I make it larger. The sync logical node of the Siemens, which would match with the rsync logical node. But I see something else. The data objects are not matching because these are the optional ones, which Siemens doesn't have by default, but I can click this to create it. But I will do this later. But up to now, we are in a good shape. Okay. The last thing to match is the measurements, which maybe cannot be found. Yeah, the frequency in this MMXU1 is not offered. That I will ask kindly from DIGSI to create for me. Okay. But the rest is matching. The face-to-face voltage is matching. So that was all for bus coupler, which was relatively a simpler idea. But here we have maybe an advanced task of matching the protection functions, which you see that there are no matches. So for the recloser, there could not be found any match, but I know that there is one. But at least I can look because I have this function. So to have the function, you need to have this layout. Okay, sorry, I thought I got a question. Then we have this auto-recloser, and here the fault locator logical node. The Siemens would also offer me the fault locator if I add it from the library to the IED. Yeah, if you have enough function points, then you can drag and drop from the library this function. Then it will create an corresponding logical node. Then we move on with the power swing blocking. Here it is. Then we move on with some teleprotection. There we have it. And what else? The synchro check. That's in. But it's not matching. If I have good eyes, I can see that QA1 is also matching with XCBR is not matching. DSC is the discrepancy. This is also not offered by default. I would again ask for Siemens to create it for me. Yeah, I found this red now. So root again creates me a problem. Then I will select the application logical node. And also in the LPHD, I will have the LPHD. Okay, so now the first task of the project engineer to find an IED in the real world is about to be completed because after clicking to create button, DIGSI will create the missing, or not the missing, but the optional data object, which was not checked out. So I have now created, you can see from here, this not existing data objects, and I will do the same for bus coupler. Good. So the next thing is now we need to, so there is a match, there is a good match actually. Now we need to adapt the data models of these two IEDs into the physical IEDs. Okay, we need to adapt the data model of the specification to physical IEDs. Here we have the options not to really use the unused structure LD, LN, DODA. And you remember I said you could potentially technically add the communication also to the specification, but just for the sake of saving some time, we didn't do, but it's possible. And then we also mentioned that we add one setting, which is the time over current. We can say import. This will take some seconds. And then there will be some adaptation, and at the end, so even you see that the value of overcurrent is now adapted to 1200 to 500, which was our setting. But now let's have a look. So now the 7SL must be an IED of fast coupler VCU. Maybe I name it like this. And now I go to its structure. And voila. What we see here is the measurement logical node is renamed. All the rest, which I haven't defined, are not taken over. And QA1 is renamed, and the logical nodes are exactly what I wanted to have. QB1 as well, and all the rest. So I could find a physical IED which is matching my specification. And for the line, if you continue, here I see the name is taken over by DIGSI, and I want to see the structure, which is the data model of it. I see it's again a good adaptation of the data model. Even the root is defined, the LPHD is there, but you see one additional checkbox, that's the line. That's just Siemens wants to add it because of the functions of the Protect 5 devices. You cannot have a protection function without having the line logical device, but there will be no communication of it. So you see it's only LLN0. This is, you have to do this because of the design, but the rest is actually what I have defined. Yeah, good. So I think we are happy now to at least start our engineering. Yeah, the task is not over, it's just started. What was the task of the project engineer? Yeah, if we go back, what was the task of the project engineer? First, to find a device, but we need to go on to further go the tasks to complete our system engineering. Yeah, if we have time, let's see. But I will go through quickly all the tasks. Basically, it's the combination of the task, what we want to do for specifying system engineering of the substation. So basically configuring the buses, data sets, if there is functional naming, instantiate the logical nodes with prefixes, suffixes, subscribe to goose message or maybe sampled values if possible. Add one client, which is the gateway that we will use, also the project, and also reserve the report for this specific client. At the end, I will also explain why we need to instantiate the logical nodes to functions again. So we do it again because it was a specification with a virtual ID, but we do it with the real world ID. Yeah. And one optional, but it's nice to show, is assigning one of 4 addresses data points to the 655. Good. So now we found 1 or 2 IEDs which are matching, but I will leave now the Siemens environment and go back to my engineering environment, which was the OpenSCD, and continue my engineering with OpenSCD. Okay, I use the system configuration tool from specification up to the loading to IED stage as OpenSCD. Okay, now I'm the project engineer, I'm someone else. Yeah, I will open my project, which I take over from the Siemens file, but I need to do something. Yeah, that is to, after finding the IEDs which are matching, I need to go once to create this SCD file with the Siemens data type templates. Okay, they are completely matching, but I need to export these ones to, to the system configurator of Siemens, and then I take it over from there. It's just it's an intermediate stage. Okay, so I will show Siemens, which is SCD file that I used. That was the one that I have used for number 10. Sorry, that was this one, which I take over and save this. And that will be now replaced. That would also help me to check with the Siemens IEDs, with the ICT tool that I use, is showing the correct data model of what I have. But I will then come back to OpenSCD to further continue my engineering. Okay, that's also a good validation at this point to see my data model. So because I can see my IED this. Oops, this is not the one, correct one, sorry. The correct one would be, that's my mistake. Because there I see the IEDs as not Siemens IEDs, the grayed out IEDs, but I will match it because I have now the IEDs. Oops, didn't work again. I clicked on the rotor button. Okay. So I can see my two IEDs, yeah, here, and I can even see how they look like. For instance, I will continue with the data model of the communication engineering, but I just want to check the data model. As you see, the data model is also matching here. Yeah, just to recheck, just to double check. But there's something interesting, because when I load this file to OpenSCD, now I open the project that I take over from the Siemens now. So you will see that the data types, the data type templates are now changed with CPROTEC ones, because I found my match. Now I can continue with these ICD files of the IEDs. So here you see is actually the mixture. So this is my blender, and I want to make the smoothie with the ingredients I have from this SSD and the ICD. That's why I have this Protect 5 data type templates, the logical node IDs. You remember I said we had the OpenSCD IDs that will be replaced, and here is the part that SSD and ICD comes together to create the smoothie, yeah, in the smoothie maker, which is the system configuration tool. Yeah, here you see the ID of it. Okay, good. What's the next stage now? If I go back to substation section, I see nothing. Yeah, because Siemens eats out my substation section. Here you see no substation section, which is bad because I spent a lot of time to create substation section. But I can really bring it back using this update substation button, which I just need to show the OpenSCD utility file, voila, and then we got this substation section back. Now we can continue. And we have these two IEDs. I would like to engineer the communication services for these IEDs. One could be, for instance, adding one goose. So if I click to this goose button, I can now add one goose. Just name it something descriptive. Actually, we need to name this control block from the BAP. Yeah, it could be trip, for instance, but the BAP would also enlighten me. And this could be an application ID, which is the goose identifier. I would also name it something for the moment what I want to have. And the communication parameter of the goose is also important to engineer in a way that they are unique or they are distinctly identifying the application itself. And then the tmin and tmax, if you consider that this is a trip information what I'm sending out, maybe it's a good idea to decrease this, not use the defaults and use the tmin as 2 milliseconds. Yeah, these are some design details, just would like to mention here. But now coming to the data attributes. So just as an example, I will just communicate out the overcurrent trip. Here we have the access point, logical node, the logical device, logical node, and I want to communicate out the operation general with the quality. Please always add the quality, not only the status data attribute, that will allow the receiver end to also understand the quality details, which may be tests, for instance, that when IED is in test mode, that the receiver end also understand from the quality. Okay, just as a tip also. Now we have one goose. That's the goose for trip. And then we want to subscribe to this goose. Okay, how do we do this? It's quite easy. Let's do it here. I can now click to subscriber binding, and I see a trip goose is available to subscribe by bus coupler, and with one click, it's done. Yeah. now I have subscribed to this goose message. I would continue doing the same with creating another goose of bus coupler, which is sending out an information of the switchgear positions, for instance. Then I will use it for interlockings. I will create an position, an application ID, again, something descriptive. Then this would be maybe a unique one as a destination MAC address, which allows the switch to understand this better if I want to use as some filtering. Also, as I want to maybe sniff the network, I can also use this MAC address to understand what's the application or which kind of information is shared out. Okay. It's important to have some descriptive control block parameters and communication parameters because they are in the header of the goods, not in the content. And in moving on with adding some data attributes, I will not do all, but just show how to add one position information with status and quality and say save. And please imagine I have added all of this. And next would be subscribing to these positions with line bay controller. Okay, that will be also two steps to accomplish this task. For instance, at this point, maybe it's a good idea to use another tool to see this communication flow is correctly engineered. Yeah, I can save now this project and open it not with StationScout, no, not with IEDScout, but with StationScout. I have already one StationScout. Yeah, it's here. I'm running it over a virtual instance, which is running over the VMware player. And I can accept that I'm using a not encrypted communication. Then I will allocate my file that I have engineered recently, which consists of these two IEDs. I will explain why we don't have see this assignment, but I just want to check these gooses first. Yeah, did you remember we had one goose from bus coupler to line, which I can see the position information of the circuit breaker that is subscribed by the line break controller protection, and line VPC is also sending out one goose, which is the trip information, and that would be hopefully subscribed by the bus coupler. This is our intention. Also, you see the goose ID here, the goose identifier, application ID, the communication parameters, and the content and who's receiving. So it seems like we are in a good way of engineering. Yeah, it seems that our engineering is what we wanted to have. The next would be also adding some reports, right? Maybe we want to have some reports for the IEDs that I will also quickly show because we are really getting closer to the end of 12:30. But I want to have one report control block together with a data set. Okay, I can add one report control block. The ones who is familiar with Siemens always has some default control block waiting for their dynamic data sets. I don't want to use those. I will add my own report control block, and that I would name it as maybe measurements this time. And OpenSCD asked me if it's a buffered or unbuffered. So for measurements, maybe it's not necessary to buffer them to really tire the buffer because it will change based on the deadband values, maybe every now and then. Then I want to use the buffer for important events, not for measurements. And I want to have 5 clients. And what's this 5 clients information? This is the number of clients in the substation that you want to have. Yeah, this is the information you also get from the specification, maybe if you had the clients. That you know you have one HMI, you have one gateway, and then you also leave one spare control block instance for a test client like IEDScout, for instance, or for yourself. Yeah. So 5 is a good number, maybe. Then you go for triggering options. Then I would say for measurements, the data change is important. Periodically, maybe you can publish it or not cyclically, or you would have a general interrogation. This is up to your design again. And all these details would be also included in the BOB to enlighten us. An option as well, I will skip this. It's not so important, but I want to have the data set, which is consisting of some data attributes of the face-to-face voltages, for instance. I want to have always the C value, not the instantaneous value, and only the magnitude of it. is a structured data object that includes more data attributes and even the basic data attribute type. But I know that I will get the value of it, the measurement value of it together with the Q. You can imagine I have done this for BC, CA, and also for Hertz, the frequency, and I saved this. Yeah. At this stage, if I look for the publisher, I can see that my IEDs are publishing clues, and one IED of I had just recently engineered having one measurement. Where was that? I seen that. Yeah, here. There we go. We had also some measurements. I can also look for the data sets. Yeah, it's also no problem. What is it consisting of? Good. So we had the goose, publisher, and receiver, but who is the receiver of this report? Would be really cool if we have the report receiver defined in the SCR file. I'm saying cool because most of the files I have seen in the wild is not having those, but it would be really nice actually for a good engineering practice to have the clients also defined in the SCR file. I will do that. Yeah, I will add another IED to have this client, and I will add another client. For that, I will use the Siemens offered clients because I have a Siemens R2 with me, and that you can find if you are like here. Each time I'm struggling because my memory is not so good, but in Siemens, in system configurator, in the ICD path, you have these dummy clients. Yeah, I want to have this ICD file of the client, the addition to client. I open it up. Then it shows up here, the Siemens SciChem client. And then I can assign the report to this client using this linked button. Yeah, I can say these measurements would be assigned or reserved actually for the telecontrol interface of this logical node at the access point S1. Okay, with that way, I assign the report control block of this line BPSU to Siemens IED. If you don't believe me or want to check once more, you can do it gladly with StationScout by importing the SCR file again, which means just updating the chains because StationScout knows what has been done in between. So we will see one more client, and then we see this green arrow, which is the report that we want to send. That was for the moment the face-to-face value, if you remember. Okay, so our engineering is going well again. So we have accomplished the task of goose, publish and subscribe. We have accomplished the task of report, sending and reception for a specific client. Yeah, and let's look for what was the next task for the project engineer. We said we added data sets, functional naming we can define. I will also show this. We added the clients. And the last thing is why we see in StationScout the conducting equipment with nothing assigned. Because in the substation section, what we have engineered is having no relationship with these IEDs. Yeah. Now you might be confused because we have assigned the functions to data type templates, not to instantiated logical nodes. There is a difference, right? Because the data type templates is a section where we can freely take over to create our IED, but here we need to do something else. We need to assign these logical nodes of the, for instance, the physical switchgear to the instantiated logical nodes. That is, we do it from here at reference to existing logical node, not the templates. And then we need to select an IED. For instance, I didn't remember what I have selected, but just as an example, I think we can do it with, is this a line and CSWI? Then we can do it with CSWI for the correct switchgear. I really don't remember what it was. I think the QA1. Then in this case, we would have the QA1. And maybe it's a good idea to do the same for XCBR and silo as well. So the descriptive names helps us now to find the correct ones. Now my IED is also taken over from here at the top and placed here. Okay, I will not go through for all the process, but I will show you at the end how it looks like. So I open the project which has this assignments already done. That is the SCL file where I have the substation assignments. Okay, as you see, bus coupler is placed here, line is placed here, and we have the assignments. How we can understand the assignments? You see, these are the functional assignments, and these are the logical node assignments to the substation section. So these are the data type templates, and these are the real IEDs. And when I now import this SCL file, I would see that these question marks will be disappearing. And now I can click on the conducting equipment and see which logical nodes are there. Okay, yeah, I think we have also completed this task. And the last task is assigning 104 data point to 6950. Yeah, let's do this. To do so, we go to OpenSCD and use another plugin called 104. And in the 104, we need to add one 104 address for an IED which we want. Just as an example, it could be an switchgear position. For instance, you go to position and say next. And here, OpenSCD already assigns an TI for this double position. And also for the control, this is for the status, for monitoring direction, and for the control, another IOA address actually. When we say add, it will ask what was your CAS2 common ASTU of your substation, and what's your IOA address. Yeah, maybe it's for the monitoring direction. This is the TI of this 01, and for control direction, which is linked with the control value, that's again 1 and 02. With that way, we can also assign the 104 data points and put it inside the SCL file. So the more you have information in the SCL file, the less extra documentation you need. And the only ultimate information of your substation is in one file. Good, and we have also done these tasks. I think we can now continue with another role but something else. We need to do some IED engineering, but for the sake of time, I will just mention the next thing is making the IED engineering, but not in the field, but just project engineer does this. So he will now load an IED file. He will also make the marshalling of it, binary inputs, outputs allocation maybe. He would also need some logic because there is an interlocking he wants to define, that he can define the interlocking here, maybe these kind of things, right? We need to do also accomplish these tasks. So this is the IED engineering, the proprietary IED engineering. And what about the client engineering that we would do with the, for instance, A8000? What we do is we import, the most important thing again is the 6950 file. There we have, oops, not the correct thing, what should be here? Yeah, there we have, for instance, the 6950 data objects also matched with here randomly, but normally you could have some IOA addressing and then with these addresses. Yeah, that would be the gateway part of it. And eventually you can see all the reports of the signals. Maybe here we have like 41 signals which are reported out from the IEDs. And at the end, we might have one HMI, maybe engineered simply with a single line diagram, not with so many details, but the commands are working, the status are working, and we have an event is also engineered. Then we want to test this, okay? And that will be the IED engineering. So please assume that we have done this IED engineering. And the next thing is also creating some test cases, which I will show with the test and commissioning engineer stage. Okay, for the last, I think I will be able to make my promise if I can with the test and commissioning stage. So this is actually quite ironic, but it's true that we really want to achieve where we have less time, even some minutes left for test and commissioning, because everything we did in the specification phase and the project phase, we only spend so less time in the substation. This is our main aim. So for this task, I want to show you my simple setup. If I was in my room, I could also show the camera to show, but I have, so you need to believe me here that I had a camera, and then I have a C-Protect 5 IED7SA, and I had a SciCam A8000 here. I have not physically actually, but a virtual StationScout to test, and then simulated IED, which is the bus coupler IED, okay? The line bay is the IED what I have, and the bus coupler I would like to simulate with StationScout and run one interlocking logic test and run some signal test. I'm not going to the details of testing because I have some, I know that in the conference there will be some presentations based on this, but I will show you how it's done very simply. The job of the test and commissioning engineer is loading the files to the IEDs. Let's do this. We have load and see if it's really real, because if I want to now close this and want to connect to this IED, which is a physical IED, it would be available and reachable over this IP address. It looks like the commissioning engineer is working on progress. Now they have this data model as we wanted to have. Even we have this boost I can see, and I can also subscribe to that and see the value of it, and even sniff it maybe if I want to have just goose to sniff. So I see also the gooses in the network. That's also a good indicator, and some reports also. Okay, the next IED we want to discover is the bus coupler IED, but we cannot discover it, right? Because it's not in the network, it's not a physical IED. We will simulate it with StationScout. Okay, that's no problem. We go to StationScout now. I will import the CL file, which I have used. So the final one, just to be sure that we use the final one. And here, I think there will be no change, but just in case. Good. Now we can simulate this bus coupler IED because it's sending out some information of the switchgear to line BCU. And I tell you the interlocking logic. So if this busbar grounding switch or this busbar grounding switch is closed, then you would be not able to close this busbar disconnector. I would like to test this first. And also the other way around, if this is closed, this cannot be closed. That was the simpler interlocking logic that I want to test without having a physical IED with me. Okay, then I would like to simulate this IED without simulation flag. And I need to go online with this system. So I will look for the IP addresses and find a suitable IP address in this range of StationScout. So I would use my lucky number to connect to these IEDs. I'm saying IEDs because it's one that I simulate and this one. So if this goose is in the network, I can see it's in the network, and this IED is reachable. And I expect that this line wave protection controller would also subscribe to these positions. I can simply make a small check. I can now trigger any positions, like I can close this and see the interlocking sign. What's the interlocking sign? That's the silo. So the line wave protection control is evaluating this information that it receives from a simulated IED in its logic, receives this value, and also change its silo, the control interlocking logic node to false, because you cannot close it. So if you try, you cannot close it. But if I now open it, wait a bit, then I should be able to close it. Hopefully, yes. Good, so our logic works, and there we have a good sign. Now we can create an automated test out of that, right? We can do this. I can import a test case, which I have created, but I can show you how to create. Just we create a test case, call it logic test, and we say if this IED as this conducting equipment. When it's closed, then the signal assessment is where we want to close this one also. Open or close would be the same, but I like to work with open switches. Then I would like to evaluate the information of closing it. Okay, but I'm not really satisfied just checking this silo. I also want to send a command where we use this one. Very simple, one step, interlocking test with automated control and automated assessment for StationScout users. You would know this. And the test step is now, if this is open, you can close the QB1 if the QC11 is open, and you can close, but let's close, yeah? Then we select position change. And then next, we close it, the busbar grounding switch, then we would be false, then that will be blocked by interlocking, yeah? Just these two simple steps. I will run this. Yeah, you see that it's moving. And moving back. And not moving at all because it's interlocked. Good. This was a simple test, but I want to make it more sophisticated. I have prepared a test case for that, and I will import this test case. And Ali, sorry that I'm already a little bit late, but I will use this interlocking JSON file, but not maybe this one. Maybe import this test case that I prepared. I will import all, which would also have one interlocking. Okay, here the test is more sophisticated. I have 5 test steps where we evaluate both of them at the same time. Okay, when one is closed, what would happen to other one? When the other one is closed, what would happen to both of them? Okay, that's more sophisticated, but I want to run this very quickly. Then I will go to the client testing, so testing of HMI, which will complete my session. Meanwhile, I can take the questions if there are any.
There was a question, but I think you answered it, and hopefully it's clear about how to simulate the behavior of test mode, which you showed already with StationScout. Perhaps 1 or 2 questions from me whilst we're finishing off. And by the way, once we're doing the question and answer session, is there any more practical you need to show, Burak, or?
The last part is now coming to the end as the HM client testing, so the gateway testing, which will finalize in 5 minutes. So there will be one more.
Okay, that's fine. So whilst we're finishing off the practical and doing some questions, there's also a poll that's been started on your screens for all the participants that are still here. Please give us your feedback. We appreciate it. If you have any suggestions for topics for the future, for next year, we'd like to hear that from you. So Burak, a question about, you showed OpenSCD. Is this an OMICRON tool? And also, there's a lot of wealth of information that you've shown here. I think many people who are in the engineering design would really appreciate to watch the recording of this as well. What sort of support does OMICRON offer with digital substation engineering and specification?
Yeah, so this is a very good question. Thanks, Ali, for that. To answer the first part, OpenSCD is not an OMICRON tool. It's an open source project which belongs to no one. That's an open source thing. And the second thing is what we use it and we support developing OpenSCD. Yeah. Also, on the other question to answer is we support the utilities for the digital substation projects, mainly starting from the specification phase up to the testing and the training. So if you have any needs for this, please contact us, and then we will be happy to support also you for this regard.
Perfect. Yeah, you can continue with the.
All right. The last part is the HMI and the gateway, the client testing. So I have a client already added here. It is receiving some reports, but does it really receive some reports? How can I check? So I can go to the IED overview, and here I can see that it is now activating some reports that I have engineered. So it seems that the SciCam 8000 is enabling some reports and getting some values on the 6150 interface. Also for the bus coupler, which is a simulated IED, it is also receiving some values. Another truth, or another way to check is we have an HMI, which really shows the positions, and which we mentioned also that we have this. Oops, maybe I put it in another window, then we can share the windows. No, not like this, like this. Okay, good. So now we can see the HMI of the SciCam and the StationScout at the same time, but we divide the screens maybe, then it's a better view. Okay, so as you see, it's representing also not from the indicators, but we can also check it like this. So if I open this, for instance, I can see that it's opening up, and here you also see it's opening up. And if I send a command from here, from the SciCam HMI, then it's selected and the execution is now running, you see, and the command is also received by StationScout, and also not StationScout, is represented by the IED and issued correctly. Good. What we can do is, this was a manual test. What we do, why we don't really automate this, right? We can automate this with a test of an position data. So we can check this. Maybe I use, let me check, I have an ACC file for that with the testing of, including the test case of the HMI. Then I will go to 104 part to test also the 104. Okay, station HMI commands. Yeah, I just test the 4 switches in this bay and just evaluate this information automatically by looking to the screen of the HMI. So if there is an 3A1 closed information, for instance, which I need to close from here, then the test will go through, right? I'm checking the command direction. And I would do the same for opening. I would only do 2 steps for that, to check the command direction for 6150 is working. Okay, so these 2 steps is enough. Let's go to other direction. Now, if we send the information, the position information from StationScout to HMI, is it also working? So for doing that, I will run this test case where it will run automatically. No, not this case, sorry. I think it will be this one, I'm not sure. With this one, yeah. This is with 104. Okay, yeah, I haven't prepared that. Okay, one thing else is the 104 commands and 104 information communicated out to the A8000. Was that working well or not? I added this 104 client. More details you will find in the later sessions, but here you see that the 104 information is also in the purple color tag is working well. So this is the simulated IED, which I can change the values and allows me to really show the information in the 104 side as well. This is also valid for the commands. I can send the real commands from 6150, from 6150 side for the simulated IED. But what I can also do is with the real IED that I have, the physical IED, I can send the command that I see the information changing in the 104 side. Yeah. And the other way around is also possible. I can send the command from 104 side and see that the 6150 side is also reacting. But why not automating it, right? So we want to automate this, which we made with this. I think it's here. It's bus coupler gateway signals, which I have many signals here. I can also check this. Yeah, checking the gateway signals of bus coupler, the 104 signals are correctly mapped or not. So I will run this test case, and that will be the end of my session today. So I will run this bus coupler gateway signals. I will clear the test, and it will start. So I can make the screen bigger now. So you will see that the 6150 side, the change in the 6150 side is reacted correctly with the 104 side automatically. for the measurements going on. So this for the positions followed. That was for the simulated IED, because the advantage of using the simulated IED is I can also simulate the intermediate positions or any measurement value without making any injection to the IED, and also seeing the response. I think this is okay for 25 signals, but 35 signals takes 1.5 minutes. Yeah, so I'm coming to the end. And just last test case is for the IED, the physical IED. Good. So this was for the bus coupler IED signals, gateway signals. And that would be also one for the positions of the line bay. Yeah, I will clear this test. You will see that I will have closed open cycle for all this. But as this is a physical IED, I have a switchgear simulator here. I will issue the commands in 6 site because I cannot send a command for switching to intermediate or bad state. That you need an IO simulator for that. Good. While waiting for test to end, I will finalize my verse. And first of all, I would like to apologize for the technical issues which happened on behalf of WebEx and my PC. And I'm happy that we could make it. And I would be glad if you have any feedbacks and or also any questions meanwhile, Ali, and would complete my words with that.
No further questions, Burak. Thank you very much for the effort you've put in. I appreciate it. There is a lot of good information there. The recording will be shared, and hopefully people will get to watch it again, and maybe you can share it with your other colleagues as well who may be interested in the topic. We are still around to take any more questions if you have anything for Burak. Otherwise, again, I'd like to thank you all. Apologies for the technical issues, and hopefully we will see you in 1 hour. There will be another link sent to you if you've registered for the conference. It's not this session, so feel free to participate in the conference. We appreciate it if you do, and looking forward to seeing you all there.